In about 2 weeks, you need to turn in your preliminary project, who's going to be on your team. You self-select and come up with a preliminary data set that you think you want to work on. Now, there are a couple of different things you can do. In the last chapter of the book, it says, here's your project and here's the requirements of the project. And there's like 8 or 10 different data sources. There's Kaggle and Irvine Machine Learning Repository of data sets. And so there are government data sets. There's a bunch of different places where you can go for data. But these guys got theirs out of work. So if you have a work project, students love it. I love it when they do work projects because their bosses usually love it. Like we had a group last semester who the project was really fun. They were forecasting how many people would use their call center for the different products that they supported. And they did a fantastic job, and they were able to use our forecasting to forecast how many calls would come in a given hour for each of their products. And it was a home run for work because it helped their boss, and it got brownie points for doing a great thing for work, and it was a great project. And so if you have something like that, that's great, and then that can work. Now, the projects have to be data sets that are predictive, since this is a predictive class, right? So it has to have a predictive aspect to it, and it has to be interesting enough that it's not trivial and boring, but it shouldn't be so complex that it's kind of like the wrong place to start for people that are taking this class, for the kind of budding data people. So you don't go too simple, but don't try to predict the NCAA brackets, because Warren Buffett said, "I'll give $1 billion to anybody who can do it," because nobody can, and that's the wrong place to start for this class. A question, and then your question first.
Does it need to be a machine learning aspect to it?
Yeah, it needs to be machine learning, since that's what this class is about. But that can take you lots of different places. I mean, so I try to work with you. So I try to say yes when I can say yes, but it's got to be predictive machine learning.
I didn't see how their project incorporated machine learning.
It was, because that's what they use: logistic regression and artificial neural networks, and that's what we've been learning. So they were predicting whether it was going to be fair use or not. So yeah.
Isn't machine learning though when you can take more data and put it back into it as the product is being used?
Oh, you mean updating it later?
Yeah.
No, machine learning is really using the algorithms to do it. It's not necessarily the updating later, So no, so you don't have to do that feature. Now, I know Dr. Keith taught you how to do it, but basically for my class, you're going to try all the different algorithms that we learn to see which best fits your problem, gives you the best results, and you're going to kind of explain why and explain what it means, and you cleaned the data if you needed to do that, or you collected the data. Some of you have already told me, some of you IS people, and the majority of you are doing some web scraping to go collect some data. So that's another fun thing to do. And so you can kind of go, kind of scrape your own data if you want to do that too. I'm not saying you have to, because there are good data sets out there. Now, one other thing while I'm talking about this, some of the data sets that are out there are crap. What I mean by that is there's not much prediction in them. You'll get like an R squared of 0.05. And it just tells me it's not that you guys did anything wrong because you applied the algorithms correctly. There's just not good predictive information to work with. You know what I mean? And so I've had students come to me and say, I'm only getting an R squared of 10, 0.1. What should I do? And I usually tell them, go find another data set, because you're going to come in and some people have found really good data sets and have really cool and fun results. And if you get in here with an empty bag because your data was crap, that's not fun, and it's not good for your grade either. Now, there are some times where people have brought me a really hard problem that was worth solving, and when we worked on it, we were able to get up to an R squared of like 0.35, which is as good as could be done on the data, and I've given them a good grade. That's not the same as just a crap data set that you can't get any traction on. Do you kind of understand what I'm talking about? So I just don't want you, it's not pleasant, it's not satisfying for you to work on a problem that just doesn't give you any traction. And some of the Kaggle data sets, for example, will do that. They'll put out a data set and it looks interesting, but you go to do a couple of preliminary analysis and there's nothing in there. And I say, you should be able to figure that out in 15 minutes. Go run CART on it, and go run logistic regression, and go run, or MLR if it's numeric prediction. And you'll very quickly find out if there's some helpful prediction stuff in there. And then you can tune it. But if it's crap from the basics, it's going to be crap for Anne and all this really sophisticated hyperlearners too. Yeah? Does that kind of make sense? So you got to do the triage. You got to go in and look at some data sets, look at some of the ones that you think are interesting. Go do a little bit of preliminary work and just see if there's something in there. And if it's not, cut bait early and don't tie yourself into something that is yucky. Yeah? Yeah.
So how would you say their project is as a baseline for complexity? Because they didn't get just a normal downloaded data set. I was just curious.
They got top marks for their project, and because they did all the right things. But I wouldn't expect you to do an implementation because they built everything to put it in the website thereafter, and it's just not. We don't have time for all of you guys to do all of that, and some of you aren't IS majors anyway. You know, most of you are, but that's building the application is not a requirement. But all the data science they did, yeah. Everyone should be able to tell whether it's neural networks or whether it's logistic regression. Everyone's got to either get a clean data set or clean one up. You ask questions about data cleaning, you know, and then make sense of what all that stuff means and what features are really good for predicting and all that kind of stuff. So that as I look at it, that's the heart and soul of that project. The heart and soul from my learning objective for you guys is to go from the beginning to the end, where you have to apply everything that we've learned. And students come and tell me time after time after time how much they learned on the project. Because you have to do everything. You know what I mean? And make sense of everything. And I, as much as I try to build learning so that everything weaves together for you, I work very hard at making everything understandable and all weave together in your learning. I still have to kind of teach you topic by topic by topic. And the fact that you can kind of put it all together is really useful for your learning. Yeah, it really is, yeah. 2 or 3, okay? 3's the best. 3's about good. It's good enough because you can get some good collaboration, but everyone feels like they can really do good work, and you don't feel like you're kind of out on the fringes, and yet you're not overwhelmed. So most of the teams will be 3. Now, every once in a while, I'll let one person do one. They'll come to me and they'll say, look, I've got a project at work, it's proprietary, my boss won't let me share it with other students. Can I just do it? And I try to say yes. The default answer for me is yes, unless it's just really too simple and boring, or it's something that I don't think the student's going to be able to get a lot of traction on because the data won't let them do it. You know what I mean? So my default answer is to try to help you and to say yes when I can say yes, but I'll also do some sort of helping because I'm an expert in terms of helping you kind of say, this isn't a good one, or you'll not be very happy with this one because of this reason or that reason. Does that make sense? Yeah. What's that?
Is 4 too many?
Yeah, now I could go with 4 if it was a complex one and it made sense to have 4 just because it's a bigger thing to chew on. I could go with 4. What I don't want is I don't want you being either overly, spread too thin because you've got too many people working on it. But there's sometimes like that one, I could see 4, people doing something like that. Yeah.
You might already answer this, but if we don't choose to make a website, what is the final?
What the final deliverable would be a report and a PowerPoint show, which everyone will do, but I would make you do like an API estimator, which you can do like you can do very easily in Azure Machine Learning, where you can just set that up to do your estimator. It can be dumped off into Excel. Excel calls the API, does the estimation in Azure, and then brings back the result. Not a big deal. You know what I mean? So my goal for you is to not go build a web page, even though I could ask you to do it. My goal is to think through all this data stuff, all this data science stuff. So you've thought about the algorithms, the input features, you've gotten rid of the stuff that isn't helping you predict. You've thought through that entire process. That's the real goal, yeah? Now, for you IS guys, if you want to put it in a simple web page or something like that, awesome. But I'm not going to make it a requirement. Every semester I'll have a couple of students that just do it, and I think that's fine. You know what I mean? But I'm not expecting that to give you a good grade. Okay. All right. So again, there's good resources in MyEducator where it describes that project, where you can go look and find data sets if you can't find one yourself. Yeah. Yeah. Yeah, if you report other algorithms as well. So I don't want you just to show me just the best one. I want you to show me that this is the best because here's the area under the curve, here's what the rock curve, you know what I'm saying? So I don't mind if you do it, but I'd want you to try all of like the 10 algorithms that we're learning in class that apply and show me that, yeah, this one really is the best because it's better than these. Does that make sense? So I don't mind if you use the automated feature selection. That's fine. Yeah. Okay. All right.
Would it be feasible to collect our own data if we can't find the data set?
Absolutely. Yeah. So you can rip your own data, scrape your own data, get your own data from work or from your internship. So yeah, I actually like that better because it's something that hasn't been done 100 times before. Does that make sense? So I support that if you can get good data that way. Okay. I think those are some of the most fun projects. Okay.